Okay, guys, quickly, let's consolidate. We have just a few concepts to look at. First one is vectors. Forces, four forces A, B, C, and D of magnitude 45. Let me see if I can make this a bit bigger. Oh, I got it just now. All right, while I do that, four forces of magnitude 45, 50, 22, and 30 newtons, respectively, act on a point in the direction shown below. This picture is pixelating so much, it's hurting my eyes. Where did I get the question from? Sorry, just want to do something. I want to get something clearer. Okay, this thing is taking me back to where I don't want to go. All right. Okay, so we have four forces, and the main thing here, guys, is to remember how to do what? How to resolve. Once you can resolve, these questions are just a giveaway. Once we know how to resolve, these questions become a giveaway. Okay, so we have four forces there, and the forces are not drawn to scale, so you cannot use a ruler. Question number one: define the term resultant force. I'm sure I've told you that, guys, it's either 2 or 0. If you don't get your definitions right, you get a 0. What is a resultant force? It's a single vector that has the combined effect of 2 or more vectors. Please take note. All right? A resultant vector is a single, you must put the word single, a single vector that has the combined effect of 2 or more. A single vector that has the combined effect of 2 or more vectors. 2.2. So you're marking. Calculate the vector sum of the horizontal component of the forces. Horizontal component of the forces. Now, which ones are my problem? My problem are A and C. B and D are already fine. And what we usually do is to convert that into vertical and horizontal. So I'm going to quickly draw that out for clarity. I have a 45 newtons, just to explain again. So I have that, and I have that, and I have a force in that direction with a 20-degree angle, and this is 45 newtons. Is that fine? Is it 45? Quickly, how do we find our vertical and horizontal? I'll use yellow to show vertical and horizontal. Okay, guys, all you need to do is to draw a right angle triangle. It doesn't matter where you draw it, you must just know. Look, I could draw it here, horizontal and vertical. And instantly by doing that, if that's 90, I can do this and say 70 degrees. Okay, let's call this F1. And this would be F1x and F1y. All I needed was just a right angle and fill in the angle of 70 there. You can use the 20 degrees as well if we know how to manipulate. But are you okay with this, everybody? Talk to me quickly. Are you okay with that? Now, once you are okay with that, we also know that the one that is opposite, we use sine. So we are done. if you can think of that, the one that is opposite the angle. So I'm using angle 70. It is 45 sine 70, while this one is 45 cos 70 degrees. Case closed. The next force is 22. 22 with a 35. Okay, 22 with a 35. I want to do that separately so that you guys don't get confused. So I have that, and I have 35. Again, all I need is to complete a right angle. Look, I could do that there. All right. Down and left. Down and left. Let's just take that one back. Can you see that? Down and left. And this one will be my what? F2. Let's call this F2. And this will be F2y. You might not have used these angles. We're still going to get the same answer. Opposite. This one is 35. The one that is opposite is sine 35 degrees. And the other one will be what? 35 cos 35 degrees. I'm done with all my components. Now, I'm just extending some of the horizontal component forces. Beautiful. Look at my horizontal component. I want to draw only the horizontal components now on this. I have my F1x in that direction. That is actually 45 cos 70. I have the other one in this direction, 35 sine 35. Now, if I go back to the question, there were two already. Can you see B and D? 30 to the left and 50 to the right. Those ones, I will also include them because they are horizontal. It's 30 to the left and 50 to the right. So what do I do with my horizontal forces? Yeah, 30 to the left, 50 to the right. I'm just going to add now horizontal components. I'm choosing right as positive, so it will be 50 plus 45 cos 70 minus 30 minus 35. Please let me know if it makes sense to you. Let me know if it makes sense to you. And if you are lost, I'm just going to run quickly, but if you are lost, let me know. So give me an answer here quickly, calculators.
The first answer is 22.772 newtons.
If you add all of this together.
For the horizontal component.
Okay, can we confirm, just re-add what I did now to see if it's the same answer you got, Michelle?
Yes, I'm sure.
You are sure?
Yes, sir.
Hey, Mpan, you sure? All right, let's check. 45 cos 70 minus 30 minus what? 35 sine 35. What do you say your answer is? In.
So please try again. For the horizontal component.
Oh, wait. I wrote. Yeah, I'm correct.
I'm very sure I typed this incorrectly.
Okay, but are you okay with my diagram and my mathematics?
Yes, sir.
All right, so it's 50 plus 45 cos what? 70, is that fine?
Yes, sir.
Minus 30 minus 35 sine what? 35. 15,32. I've done it the second time. So I don't know what you did wrong. Okay, guys, we got it wrong. It was 2 marks. I don't know why they said 2 marks, but it's not making sense for 2 marks. It's more than 2 marks. Sum of the vertical components. Now, how many vertical components are we going to have? We are going to have 2 of them, which is... We're going to have 2 of them, right? And what would that be for our vertical component? Vertical will be, I'm going to take that out. Vertical, let me use blue. We have one going down. Let me make it thicker. We have one going down and we had one going up. This is 45 sine 70 and this is what? 35. Our answer was positive there, right? We need to choose right or east. Very important. What about this one? Up is positive, down is negative. Vertical, 45 sine 70 minus 35 cos 35. What is our answer? Quickly, very fast. I'm moving. 45 sine 70 minus 35 cos 35. That is your answer. 13,62. Do we agree with this? And we chose up as positive, so it's up. Do we agree? Are we on the same page? Any question? Yes. Any question? Who's asking? Okay, everybody seems to agree. No contesting my answer. Can I look at the next question quickly? You can start screenshotting, guys, because we're running out of time. Using your answer in question, draw a labeled vector diagram showing the resultant force on the diagram. And then we need to calculate, do not draw to scale, and then we need to calculate the resultant. So, sweet. You can just do all of that at once. We have one to the right and one upwards. So game over. Question is finished. We have one force to the right and we had one force going upward. And the one going upward was 13,62. And the one going to the right was 15,32. Michelle, did you find your mistake now?
I'm so confused because I did this paper yesterday and I checked the memo and then I got these answers correct. So I'm confused.
Why are you saying? Okay, wait, let's go back quickly because of you. Do you have your answers with you?
Yes, sir, I do.
Okay. Do you have 50 newtons?
I do, yes, sir.
Do you have 45 cos 70?
Yes, sir.
Do you have 30?
Yes, sir.
Do you have 35 sine 35?
I have 30. I have 22 cos 55.
Why 32? Is it 32 there or is it me? Oh, it's 22. Where did I? Oh, guys, it's me. It's 22. I don't know why I saw 35. And people are just copying. It's 22.
Yes, sir.
But you didn't tell me.
I didn't see.
And everybody just agree. Hey, my learners. My beautiful learners. Guys, you just agree. If I didn't go back now, we would have been doing something wrong. We don't agree. People pay attention. It shows that you're not paying attention. We're just copying. 50 plus 45 cos 70. Guys, please don't agree. 22 sine 35. What was your answer?
Yes, so that's exactly the answer I got.
Okay, 22,77. Guys, please don't agree. It means you are not following. That's what you're telling me. Somebody could have argued and thought, sir, where did you get the 35 from? Please, it shows me that we are copying. Because I made a mistake writing the angle there. It means we are copying, my dear learners. We are not doing physics. And in the exam, you have to do physics by yourself. What's the answer to this one?
It's 24.65. No, 265, sorry.
265, 27.
Yes, I like that.
Guys, I hope we are learning a lesson here. Don't just copy, please. Don't just copy. Challenge the answers. 24,27. And it means you guys did it wrongly. That's why you didn't even see that I'm wrong. Okay, quickly, what's our resultant going to be like? We need to complete the triangle by drawing a parallelogram and then draw my resultant. So what is our F resultant? Squared. 22,77 squared. Can I please ask you to give me an answer? Everybody quickly calculate. Please. Some of you don't even have calculators with you. Okay, Michelle, can I ask somebody else to do it? Because some of them don't have calculators, they just copying. Whatever that guy writes, I'm going to write. No. I need answers as quickly as possible. Yes, McCarthy?
So is it wrong if you say r squared and the root of 22,7 squared plus 24,27 squared?
Yeah, you need to find the square root of your final answer.
Okay, sir.
Guys, can I get an answer? 33,28. Rosemary, your answer cannot be 1107,51. Rose, fix it. (33,28). You need to find the square root. Now, what about the angle? We need to find the angle. We can use this to find the angle. All right. If I'm looking at that, that becomes my opposite, and that gives me my adjacent. So we can say tan theta, which is opposite over adjacent. Remember, this one is 22,77. I hope we get that. Over 24,27. Please give me an angle for theta again. I don't want to do all of these calculations for you, because we spoil you when we do the calculations. Get me the angle theta. That's trigonometry from grade 10. Yes, Michelle?
At opposite over adjacent, there is adjacent over opposite.
What do you mean?
So you wrote it as... Oh, okay, looks like I'm wrong again. Sorry about that.
Okay. Kutlwano has 43,17 degrees. Yes, Tegofato?
So isn't tan over y?
Sorry?
Isn't tan over y?
Tan over y.
No, tan cosine over y.
X over y.
Yes, isn't it supposed to be 24,27 over 22,7?
Y over x, tan.
So you swapped the x and y value
Who swapped it?
on the graph.
Our vertical is what? 24,27.
Yeah, so you put it as a horizontal.
Oh. 24,27. Again, I have people who are just copying. People are just copying. Copying. That's all they know. But Teho, it is y over x, not x over y.
Okay, sir.
That's why we call it SOHCAHTOA. Opposite over adjacent. And again, people, my mistakes are just showing that people are just copying, not making follow-up. Okay. And I'm sure you are also waiting for me to get an answer, right? And I'm just gonna chill, waiting for you guys for the 6,83. Degrees above the x-axis. Your answer must be written like that, either above or below, or above the positive x-axis. I need to add that, above the positive x-axis. That's how we make our reference, above the positive. Thank you, Rosemary. Rosemary could pick it up. But that was after I corrected it as well. Anyway, guys, I'm going to question the next one, Newton's laws. But please, let your heart be in it. So don't just copy these things. Some of you are just copying. And that's not, my mistakes are actually revealing a whole lot of stuff. Quickly, I think we might have about 4 questions to do. And we don't have time. 9 marks here, 10 minutes tops. 10 minutes tops. Come quickly, everybody. Make it 11, 12, because you have to read. I might extend 30 minutes more today, so I will finish, but let's run. Right, let us mark quickly again. Time is up. A lighting extensible rope is attached to a vertical wall at point X. A block of mass 2,1 is attached to the other end of the rope. The rope is pulled out to the left. The horizontal force magnitude of 28 applied at point Y as shown in the diagram. The rope makes an angle of theta with the wall. Draw a closed vector diagram. A closed vector diagram means you must draw it as a rectangle to show all the forces acting. First thing that I will ask you to do is to first draw a free body diagram to make life easy for us. So look at this. This is like that. Let me use white. That is like, why is it changing to white? That's our tension. That's the weight. And that is F. So F, weight. So if I want to draw a closed diagram, I must draw this to give me what? A triangle. Now, let's see. Can we rearrange this for us to get a triangle with all that forces still facing that way? Okay, let's try. Let's try a triangle. Okay, so if I were to keep this way, all right, if I were to keep that way and shift this one backwards, check, and put this one down, can you see my triangle? If you notice, everything is like that. My W is pointing down, my F is pointing left, and my T. Does that make sense? And this angle is theta. 4 marks. 4 marks done. Did that make sense to you? So make sure the diagram, the angles are facing, the lines are facing where they are originally facing, and play around until you get a triangle. Calculate the tension in the rope. Calculate T in the rope. Guys, never leave, to make life easy, don't leave your forces as inclined. That's how you're going to get it very easily. I'm going to have that, which is my F there. I'm going to have that as my weight. Now, when I resolve, one up and one right. This is my weight, which is mg. This is my F, which is 28. Now, because I have resolved this, if I were to go back to show you the component, remember what we said. Try to get a right angle, what? Triangle. Right and up. And that's 90 degrees. I'll call this TX and I'll call this TY. And that's my angle there. The one opposite, we use sine. I'm repeating the same thing. T sine theta. T cos theta. If you don't get this, then we are not going anywhere. So I want to ask, is there anyone who is lost with my usage of sine and the usage of cos? Please let me know. If you are okay, give me a thumbs up. If you are not okay with my sine and my cos, vertical and horizontal, give me a thumbs down. We're not going anywhere if we don't get that correct. I'm checking. I'm not getting. I didn't see a response. Maybe I missed it. Okay, from Lindy, where I was going to mention. Rosemary, did I get yours? Okay, everybody seems to be okay. No one is giving me a thumbs down, because that is very, very key. That is very, very key. Now that I know that this thing is stationary, what am I looking for again? Okay, weight is going to be 2.1 times 9,8. What are we looking for? We are looking for the tension in the rope. How can we get the value of tension in the rope? Anybody? Then we would need to get the angle theta. Yes, Michelle?
Using Pythagoras,
if we use Pythagoras, what are we? Is that going to give us the tension? Let us see. Somebody else raise their hand. Let me listen to somebody else. Benjamin?
So by substituting W and F in T cos and T sin.
Okay, will that help us? Let me quickly get a fresh page and see. Okay, let's see. Misha, if I were to use Pythagoras, why would I use Pythagoras though?
So it's because it's a closed right angle triangle where patient represents the hypotenuse.
Absolutely. Guys, look at that diagram that we had there. And that's the key. That is 90 degrees. What's our W? 2,1 times 9,8. What is our F? 28. So T squared, F squared. All right, everybody, please work it out for me in case you didn't work it out. Benjamin, I want to quickly deal with what you said. And I want to show you something quickly. 2,1 times 9,8 would give us what? 20,58. All right, please everybody give me an answer to T using Pythagoras. Benjamin, if I equate, do you notice that I'm going to have two unknowns?
Yes, no.
Let me see if I'll still get it, but no. I'll have two unknowns. There's no way I'm going to get it. I'm going to have, and I have different trig ratios. It's going to create a whole lot of problem. So it's better with this one using that triangle. Make sense?
Yes,
All right. What's your answer for T, everybody? Don't let's waste time. What's your answer? Is this a fresh answer? 34,75? All right, 34,75 newtons. And once you have that, you can then work this out to say for theta, F equals to what? T sine theta. 28 equals to what? 34,75. Now work out the value of T, and we are done with this question. All right, I hope that makes sense. I hope that makes sense. Quickly, work out the value of theta for me. Okay, 53.68. Those of you that are not giving me answers, I hope you are not just copying, you know how we got those answers. Very important. I always like when everyone in class is participating, and if you are not getting that answer, you raise an alarm as quickly as possible. Guys, let's do some Newton's laws quickly. Let's do calculations before I come, if I have enough time, come back to graphs. Let's look at this one, 5 point, let me see. Yeah, this looks like a very good one. Let's look at this, 2, 2, 3, 1, that's 4, 7, 8. 10 minutes, because I see there's a bit of some calculations there, 10 minutes plus your reading time. There we go. Were we able to make sense of the question, people? Can I get your response? Were you able to make sense of it? A box of mass 100 kg is at rest, and I told you how to read this, right? I told you how to read. The underline mass talks about the weight at rest on a rough horizontal surface, friction and normal there. When the force of magnitude F is applied, and the object moves at a constant velocity, we know what that means. Acceleration is equal to 0. The coefficient of kinetic friction, these are important points, 0.5, show that the magnitude of the normal force. Never do anything without drawing a free body diagram. So if I'm drawing a free body diagram, what do I have? I have my force applied, I have my weight, I have my normal force, and object is moving to the right, being pulled to the right, friction is going to the left. So friction, weight, which is gravity, normal, and force applied. The problem is my force applied is not vertical. So what do? We always resolve. See, I'm doing the same thing over and over again. That's what physics is all about. Now, I have my normal force. If I were to resolve this, one is going to the right. That should be an arrow. One would go to the right, and one would go up. So I have my normal, my Fy, I have my Fx, I have my weight. It's with guys, we're repeating this in all the questions we've done. This is repeated. Now that I have my 15, if I go to my diagram and do the same, my right and my up, and I have my 90 degrees. Fy, Fx. Fy is the one opposite. Opposite, I use sine. I'm sure you should be hearing my voice in your sleep about that. Opposite, we use the sine. So, F sine, what, 15. Once I do this, F cos 15. What is the weight? mg, which is 100 times 9,8, which is 98 newtons. Yes? Talk to me, Benjamin.
So,
yes.
Fy is F sine.
Oh,
F
at least somebody is following at last. F sine, like we wrote there, F cos. Okay, at least somebody is following. Thank you, Benjamin. Now we are looking for what? The normal force. And you would see in this case, there are two forces pointing upwards, which must be equal to my W. Why? Because the object is at rest. So, F plus, let me do this. Let's duplicate. So what do I know? F plus Ny, N plus Fy rather, N plus Fy should be equal to the weight. What is my normal? W minus Fy, which is mg minus F sine 15. Wait, let me see what we are proving. Oh yeah, our answer is there. 100, 9,8 minus F sine, and what will that give us? 980 minus, what is sine 15? Tefufatu, talk to me.
The 98.
Sorry?
980.
You said what?
You said 100 times 8 is 88.
100 times?
9,8.
Yep.
You said
it's 980.
Yes, take the by W.
Oh, okay, I'll fix that one. Oh, that one. All right, it's fine. I'll fix it. Thank you. I'll fix that. 0.2588. I'll fix that. Oh, yeah, I see what you're saying. 980. Okay, which I have corrected. Okay, question done. Do you see? 0.259. They rounded up. Done. Calculate the magnitude of the frictional force acting in terms of F. What is frictional force? It is mu k, mu kn. And what is the coefficient? We're given 0.5. And our normal force is 980 minus. So if we multiply that in, what is 0.5 times 980? That should give us 490 minus, what is 0.295 F? Anybody giving me an answer there? That should be 0.129 or 130. Yes? Somebody's raising a hand. Zero comma 259 times 0.5. Yeah, 0.1295 F. And this is Newtons. There was a hand. Are we okay? There was a hand. Let me just fix this. All right, let me know. Are we okay? Thumbs up, thumbs down. Are we good? Just trust the system and walk through like that. Just trust the process. The principles don't change. Hence, calculate the magnitude of F. Beautiful. And to get F, let's see, what can I use? Now I know friction, so I can use my horizontal. I can use this. Because I know it's at constant what? Velocity. So F cos 15 minus my frictional force should be equal to 0. Oh, I have the diagram here as well. So F net, now let's first write the formula. F net equals to MA. I'm choosing this as positive, direction of motion. So F cos 15 degrees plus friction equals to MA. F cos 15. Now, friction would be what? A negative, remember? Plus minus friction. So minus 490, algebra here, 0.1259 F equals to 100 multiplied by 0. I don't know if my maths is math in there. F cos 15 minus 490 plus, let's be smart with our calculator usage, F cos 15 plus 0.1259 F. Some of you are already on calculators here. There's no need. What's common? F cos 15 plus 0.1259. What do? We divide both sides. So what's our answer for F? Easy peasy. 490 over cos 15 plus 0.1259. Boom. Answer is there. 448.79. Is that what you got? Makazi, what did you do wrong? That means you did not follow the principles of physics. Lindy, where is 700 coming from? Ribotile, why are you giving me a thumbs down? Okay, but let me know, whatever I did, is it making sense to you? Whether you got it right or wrong, whatever I did it make sense? So you can take screenshots. You can take screenshot of that. So guys, you would notice the principles don't change. They just remain the way that I taught you. Free body diagram, analyze, and you are good. Let's see what's next. What's next? How will the magnitude of the frictional if the size of the angle is doubled? If you are not sure here, all you need to do is to do a simple calculation, because that would definitely change if the angle is doubled. Yeah, it will definitely change, because if the angle is doubled, the normal force will also change, right? So in an exam, if you are not sure, don't cram it. Okay. Let me show you what I mean. Now that I have my F, I could just go back here and simply calculate. But if you know physics, let me try to explain without a calculation for you. If I don't want to calculate, everybody please look up. All right, so we are looking for friction, right? And friction has everything to do with normal force. So watch this. I have that. I have my normal force. And I have my F there. And then I have my weight. Okay, so friction, normal, Fy, and the weight. Okay, let's look at this. Friction is directly proportional to normal. If my normal increases, my friction would increase. So the question is, what happens to your normal? Normal is equal to, let me start like this, plus Fy is equal to the weight. So normal is what? W minus Fy. Watch this. Now, whatever my F is, we said F sine what? Theta. Now, this would give us a particular force. What I needed to see is if theta is doubled, what happens? This is what you need to check mathematically. What is, let's look at an angle. Let's use a special angle. Some of you did trigs last year. What is sine 30? Sine 30 is half. What is sine 60 degrees? Root 3 over 2, 0.8. Do you notice that if theta increases, sine theta also does what? Increases. That's my first statement that I want us to see. If theta increases, sine theta increases. Oh, that means, therefore, F sine theta will increase. Oh, it therefore means N will decrease. Why? Look at the formula. N is W. This value is becoming bigger. Hence, this value will become smaller. And if N decreases, Fk is directly proportional to N. Therefore, Fk. Look at an outlay. That's a complete understanding of what's going on. it decreases. Lindy, it decreases. Are we okay, everybody? Is my explanation making sense to you? So in an exam, you try to make your way out because you don't want to cram this thing. You just want to outlay it, and look at my outlay. Very beautiful. Connecting. If F increases, sine theta increases. If it was cos will decrease. All right, F sine theta will increase because I'm now multiplying by F, n will decrease because of that formula. If n becomes smaller, the friction will decrease. All right, I think that is all about that. I'm going to end the session here, but yes, let's see. Benjamin?
So how would the statement be if they say they want a reason?
They want a reason.
Yes.
That's all I need to write down. Write it in points. Just write that down. Examiner knows, oh, this person knows their story.
Yes, sir. Thank you, sir.
Okay. All right, let's see if we can. Gravitational, okay, we are not doing this yet. Gravitational I looked at last week, right? But let's see if we can quickly, oh, there's a gravitational here. Okay, let's see if we can answer 5.2. Like I said, I will take a bit of 30 minutes because we started late. I was busy with the other grade. Okay, let's see this one. 5 and 3 marks. I don't want to do it for you, so I'm giving you, let's see. Can we do 10 minutes? Then we mark together. 10 minutes is too much. We're just drawing a free body. No. 6 minutes. Quickly. 6 minutes, 30 seconds. Let's go. You're drawing a free body and then you're calculating tension. Okay. Did we manage? A crane lifts two blocks of masses 150 and 200 kilogram as shown. The 150 accelerates upwards at 0.7 meters per second. Draw a labeled free showing all the forces acting on the 150. Okay, how many forces are you drawing? On the 150, it's been pulled up, so we have tension. Okay, and then what do we have? We have it going down, Fg. Or tension 2. And there's also, okay, so the weight is going down and tension 2 is also acting downwards. It's being pulled downwards by the other tension, tension 2. Try to make sure it is very straight, or you can draw it over each other. Okay, my diagram just keep getting skewed. All right, better. So we have T2, we have Fg, and we have T1. Do you agree with my diagram? Okay, calculate the magnitude of tension T1. The object is being pulled up, so let's take upward as positive. And we take downward as negative. Okay, let's see. Acceleration is 0.75. So if I use my F net equals to MA, what's going to happen? It's going to be T1 plus negative T2. All right. Plus negative Fg is equal to MA. Problem is I don't even know T2. But I know this is mg. Okay, so T1 minus T2. What is the mass again? 150 times 9,8 is 150 times 0.75. So I know that T1 minus T2 is, let's do the maths together quickly. If I multiply my right hand side, is 150 times 0.75. And if I move that other one over, it becomes a positive 150 times 9,8. Okay, so T1 minus T2 is 1582,5. May I ask, is that making sense so far to you? Are we in agreement with that? Again, using the basic principles, we're repeating the same thing over every question. Now I have two unknowns. It means I need a second equation. Where will I get my second equation from? I'll get it from the 300. 300. So, free body diagram, always draw. Don't be lazy to draw. The weight and T2, which is mg. Object is going up again. F net is equal to ma. So T2 plus negative mg equals to ma. I hope that makes sense. So T2 minus 300 times 9. Oh, this actually gives us our T2 straight. What is the mass? 300. Oh, so we are done here already. We can get our T2. So what would T2 be? Again, get your calculator. 300 times 7,5. If I move that one over, it becomes positive. 300 times 9,8. What would that give us? 5190. Oh, now I know that T1 minus T2, I don't remember what we got. 1582,5. Oh, so it makes sense. Move that over. 1582,5 plus 5190. What's your answer? And we are done. $51.90. That would be 9. That is 2. 8 would give me 7. 6 would give me 7. 6 again would give me 7, comma 5. Is that what you have? 7772, comma 5. Confirm for me. Yes, Michelle?
So as you were calculating, you multiplied a value by 7.5 and not 0.75.
You sure?
Yes, sir.
Let me see. Did I miss the 300? 0.75 plus 300, 9.8.
Yes, like that, sir.
Oh, 3165. And 3165 plus so what's the final answer if you add? 5 plus 2 would give me 7. 8 plus 6 would give me 14. 5 plus 1, 6. 1, 7. 3 plus 1, 4, comma 5. Okay, so that's how we get things done. Gravitational, although we did that just of recent, which was just last week, let's just answer this 6 marks, 8 marks question. Oh, I'm not going to state the law, guys. You are going to state the law by yourself. So I'm just going to ask you to do 5.3.2 and 5.3.3 in 5 minutes. The law, please state the law when you are studying. For now, I just need those in 5 minutes. All right, and then we go again. Of an object falling freely near the surface of planet Mars experiences a gravitational acceleration of that. So the G here is 3,8 meters per second squared. The mass of the Earth is that. Calculate the radius. Now, I gave you a formula for G, if you remember. G is G mass over R squared. If you remember that formula, you are done. Now, what is our G? Small g, acceleration due to gravity, which is what we are given. 3,8. Now, what is this G? 6,67 times 10 to the power. Let me just confirm that value. If you check on the formula page, you will see it there. 10 to the power 10 negative 11. Now, what is the mass of mass? 6,4 times 10 to the power 23 over R squared. Now, if you cross multiply, yes.
So, does that gravity constant that we get on the formula page also apply to Mars?
Yes. That G is constant.
Okay, thank you, sir.
Okay. Now, if you cross multiply and divide, you're going to have 6,67 times 6,4 times 10 to the power 23 over what? 3,8. And then you find the square root. Can somebody please give me an answer? Somebody please give me an answer. Yes. Benjamin?
So,
Yep.
3,39 times 10 to the power 6 meters.
Can somebody please confirm? Thank you, Benjamin. Can we have a confirmation? I'm waiting for you guys. And as usual, some are not bothered. Yes, Tekofatu, talk to me. Teko, your hand is up. What are you getting?
1 comma times 10 to the power 30.
1 comma
1 comma 1 times 10 to the power 30.
Okay, so guys, which one are we confirming? Yes, Lindy?
So I'm also getting 1 comma 1 times 10 to the power 30.
All right, can I have another person? We're so many that I shouldn't be doing this in class. Benjamin, please, can you recheck your work? Because it's 2 answers against you. Kutlano?
So I'm also getting 1,12 times 10 to the power 30.
Benjamin, can you please check? Viwe, Rosemary, Michelle, McCarthy, can we just assist? What are you getting? Ribotile, Pulisani, Ndubo, what are we getting? Because that's calculator now, and I'm not going to bring out my calculator. My calculator is tired. Yes, Michelle?
So I'm getting a completely weird answer.
Guys, am I supposed to type this again in grade 11? Huh? Yes, Tegufatu?
So now I'm getting 3.35 times 10 to the power 6.
Amen. Yes, Ribotile?
It's only 3.39 times 10 to the power 6.
Wow, guys. Makati? Guys, we have the same sum. We are all using the same calculator. May I please ask everybody to do it again, afresh now. Type everything at once in your calculator. We should all have the same thing. Because the difference is not making sense. I've done the hard work. And this should not take us more than 15 seconds to 20. Please, in the next 20 seconds, I want answers. Yes, Benjamin?
So I'm getting 1,112 now, so
1 comma?
112.
1,112 or 1,12
1,112
times?
10 to the power 3.
Okay. Who gave me? Some people are not even talking to me at all. Yes, Ribotile?
See, I'm getting 1.12 times 10 to the power 30. But when I put it under the square root sign, then I get 3.39 times 10 to the power 6.
Guys, are we finding the square root though? It's r squared. So, Ribotile, your final answer is what? 3.39?
Yes.
Yes, Tegufatu?
So I'm still getting 3.35 times 10 to the power 6.
3.5 or 3.9?
3.35.
Okay, guys. If we are getting different answers on a calculator, then I don't know what the story is. Sian Temba? Yes? Michelle?
So I'm getting the same, it's 3.35.
So where is the 9 coming from, guys? I don't understand now. If it's 3, okay, let me just do it. But this is not nice, guys. Grade 11s. And I have people who are not even saying anything, and that's not good. 3.35. Yes?
No, I was going to say I'm getting 3.35.
Yeah, 3.35. All right, what is the weight of the object? How do we get weight? On the Earth's surface, mg. But since it's the Earth's surface, we are not using 3.8. It is 9.8. The 3.8 is on that other planet. Let me just do this one because I don't want to argue with answers. $63.21. I don't want to argue with answers. I hope all of this is making sense. Please, guys, the calculators begin to worry me right now. I'm beginning to get worried. And I am more getting worried on people who are just there, who don't do anything and don't give any answers. And I'm going to mention their names now so that you know. I just want to talk over this. People who don't participate, and I think I'm going to take very, very important measures against that. Let me see. Viwe never gave me an answer at all today. CM Timber never gave me an answer. Ndubo never gave me an answer. Makati asked me one question, never gave me an answer. And and you guys should know I chat with your parents, right? Because they asked me, and I'm just going to give them a feedback that you are only here to copy the work. Okay, I'm not really going to do this, just want to talk over it. A physical sciences class set an experiment to investigate Newton's second law, which most of you must have done. And you have the reading on the graph like that. The net force acting on the trolley was increased by transferring mass species. The experiment was done 5 times, and da. Now, state Newton's second law of motion in words. That's on you. You should know that. Write down an investigative question quickly. How do you do investigative question? So I'm giving you the lowdown on this, and then we'll be shutting down. Investigative, because you can be asked this in an exam. All right, this is what you do. How will you state what the independent variable is. You state what that is. Affect the dependent variable. You also state what the dependent variable is. The question is, how do I know my variables? Quickly talk about that. Number 1, independent is what I am changing. What I am changing. What I am changing. And in this case, you would notice we said we are adding more force masses to change the force. So in this case, it is the force. Number 2, the dependent variable. This is the result. As we change the force, what is changing? The acceleration of the object. Number 3, you must have a control variable. Something kept constant. Variable that is not changing. And this is to make the experiment fair. If they ask you why do we need a constant variable, it's to make the investigation fair. So the question is, what are we keeping as a constant in this whole experiment? What are we keeping constant? If you go back and read the whole thing, do you notice we are the mass piece? The net force is on the trolley was increased by transferring mass piece to the trolley, from the trolley to the hanging mass piece. So what are we keeping constant?
Keeping the total mass in the system constant.
Absolutely, the total, because we are just transferring. So the total mass in the system is constant, because we are removing mass from one point to the other. Okay, so that's a quick lowdown there. So in this case, you just write, how will the change, how will, let me add something. How will, please just add something there. Let's clean that. How will a change, I missed that word, in. So just put that. How will a change in the force, independent, I missed the spelling there. How will a change in force affect the acceleration? Okay, and state one variable kept constant like we discussed. Write down the numerical value of x and y given in the table. Numerical value of x and y. I think you can actually see this. How are we getting the net force? Do you notice net force? We are saying 100 times 9,8. We have 0,98 there. Remember, this is grams, right? We need to convert to what? Kilograms. So this is converted to kilograms, divided by 1,000. This is what? 0,1. If you multiply that by 9,8, you are going to get 0,98. Physics, we always work in kilograms. Do you see that? So it means this one as well would be what? 0,5. And what is 0,5 times 9,8? That would give us 0,49. Lovely. Oh, no, sorry, 4,9. 4,9. Because it's increasing. Now, if you look at the acceleration, you can see a constant change from 0,5 to 1, 1 to 1,5, 1,5 to 2, therefore 2 to what? 2,5. 2 marks. Calculate the gradient of the graph. I'm sure that is easily doable. y2 minus y1 over x2 minus x1. I can simply choose those 2 points, point 1 and point 2. Can I ask you to please get me the gradient quickly? Let's get gradient. y2 minus y1 over x2 minus x1. I'm waiting for that, guys. By 9 o'clock on the dot, I need to shut down. Not 1 minute after 9. That's 2.5 hours of class, which is very, very good. But like I said, I have people who are not going to respond to me. Even if their answer is wrong, they don't respond. Let's see, maybe there's a change of heart. All right, thank you, Kutlano. Thank you, Rosemary. And that's Kutlano who just joined us today. You can see the participation. All right, y2 minus y1 over x2 minus x1. Thank you, guys. Okay, so if I'm picking my values, 1 second, guys. If I'm picking my values, okay, so y2 minus y1, quickly I'll do it here. Gradient is y2 minus y1 over x2 minus x1. Now, our y2, okay, this graph shifted, the 1 is supposed to be here, right? So 1 minus y1, 0.5 over x2, 1.96 minus 0.98. Is this what you did that got you 0.51? Okay, quickly, 4.6.2. What does the gradient represent? My good learners, how do we do this? Change in y over change in x. This is, so you do it mathematically. Gradient is change in y. Now you look at what's on the y-axis. What's on the y? Acceleration. What's on the x? Net force. Check. Acceleration over net force. That is gradient. I'm going to go to my formula now and see, can I get A over net force? My formula that I know says F net equals to what? MA. Let's play around the formula quickly. Let's play around. I'm looking for A over F net. Oh, okay. Let's divide both sides by A. F net over A equals to M over 1. But I'm not looking for F net over A. Oh, if I flip it over, A over F net equals to 1 over M. Do you notice that this is my gradient? So my gradient is equal to 1 over the mass. Did this make sense? Did that make sense, people? You get a formula from the gradient and then you go and match it with the formula from. Okay, Kutlano, I'll be done, all right, in the next 30 seconds or so. Okay. So gradient is 1 over mass, and that's what, are we okay there? What quantity? 1 over mass. The examiner says now calculate the mass. Oh, simple. I know that my gradient, I told you by 9 on the dot I want to finish, is 1 over mass. But what is my gradient? 0.51. Ah, beautiful. I can also reciprocate this 1 over, or you cross multiply if you want to cross multiply. If you want to put this in a calculator, I have about 30 seconds left. Or some of you that don't know that, you can cross multiply. 0.51 multiplied by m, divide both sides. Do you see I'm getting the same thing? What's my answer for the mass? Okay, Kutlano, do you see that it's not mass? It is 1 over mass. Okay, it's not mass, it is 1 over mass. 1.96. One second, I just want to check something. Okay, yeah, fine. 1.96 kilogram. And I am done. Good night, everybody. I said 9 on the dot, and I think it's 9. I hope it all makes sense. For those of you writing tomorrow, good luck. This lesson will be available immediately on the group. You can rewatch. Yes, somebody's raising their hand. All right, cheers. Good night. To those who talked to me, to those who did not talk to me, good night as well. Good night, everybody.